welcome back for, I guess this would be scene 4 of our solar power system installation series. For this video, we're going to look at one of the two charge control units that we've acquired in yesterday's delivery of 2 pallets. Part of what I wanted to show you yesterday wasn't so much how we do this or getting you overly familiar with the equipment, but just kind of showing when it shows up on the truck, what does it look like. Yesterday we had a big semi pull up in front of the house, and truck driver gets out and starts unloading pallets, and on those pallets is what we have here. So that was mainly just to kind of show you what to expect when it arrives. If you order a smaller load, they might use something like, I don't know, FedEx or UPS or something like that. Something this big, they're going to use a bigger carrier like RL or someone like that maybe. What we have here is a Xantrex solar charge controller. And what makes this a little different from a typical battery charger is that it's smart. It has brains. It's networkable, and it's part of those brains are programmed specifically for the purpose of dealing with solar sources of power. Now, we've ordered 2 of these, and they go for around $500 a piece. And it's roughly the size of a shoebox. A little longer, a little narrower. But if you have long, narrow feet, it's about the size of a shoebox. This unit is designed to have a maximum capacity of 60 amps. And since my system has a estimated somewhere in the ballpark of 100 amps plus or minus 20 amps. I don't have the calculations in front of me, but I calculated that I'd need 2 of these. And you can see it's probably got some little localized interface controls here on the front of it, but it also has network features, which I'm getting ready to show you. Has nameplate data on the side. This particular model is the Xantrex XW-M, as in Mary, Paul Tony 60-150. And those specifications are maximum photovoltaic voltage operating of 140 volts, open circuit voltage of 150 volts, and battery charge current of 60 amps, maximum battery charge voltage of 72 volts. The auxiliary output terminal is 5 to 13 volts DC with 200 milliamps, and minimum interrupt rating 4,000 amps. Has a serial number. Date of manufacture was October of last year. And here in a second I'll take off the cover plate and we can see what's inside. Get my handy dandy cordless screwdriver. No one wants carpal tunnel. Make sure when you put your tools away, you always alphabetize their location. Oh, that was my anal retentive carpenter take there. Alright. 2 screws. Take the cover plate off, and that exposes this part. And what we have here is 3 connectors. One of them has a terminating plug in it. The end of the line device, if this were the very last device on your network, you would put a terminating plug in one of the network ports. Basically, every device in the Xantrex network system, or Xanbus as they call it, has a incoming port and an outgoing port. So you would have a Cat5 cable with an RJ45, much like an Ethernet cable, coming in to the first device and then one coming out going to the next one. The beginning of the loop, generally I would expect to be the inverter itself or even the control panel. That then the control panel might go to the inverter might go to the first charge control might go to the second charge control, and so on and so forth. I have to look at the documentation and confirm whether the inverter or the control panel would be the first device in the loop. Shortly after this, we'll show you the control panel. There's a third connector here. Looks like an RJ11, which commonly known as the standard phone plug, whereas an RJ45 is typically known as a Ethernet connector. Another thing that came with this that I find pretty nifty is this little doodad. And this plugs into your phone jack or your RJ11 port, and there's a little double-sided sticky tape here that peels off, and this mounts to your battery. We have batteries right here, as you can see, and what you would do is stick this to the appropriate place on the battery. Not sure where that would be exactly yet. And this monitors the temperature of your battery by the charge control device. And if you have an over temperature situation in your batteries, this will let it know through that connector. And then you would get an alarm somehow, whether it be through faceplate or through your network. Since this system is network monitorable, there is software and hardware that can be utilized to make this accessible on your home network if you have one. Down here, you can see that we have a battery plus and minus and a PV plus and minus. PV, of course, meaning photovoltaic. There's a KLK fuse in there. I'm not sure of the rating, but that's a type CC fuse, I would think. And we have a isolation barrier here to separate our power system from our control system. And then down here it looks like we have a couple of either maybe 3/4 or 1 inch knockouts. There being 3 on the bottom, 1 on the left, and 1 on the right. The minimum clearance for these devices is 6 inches to the left, 6 inches to the right, and 6 inches on top. That is the manufacturer's clearance for breathing room. You'll also need to check with your National Electrical Code and or local codes for other requirements pertaining to clearances about electrical equipment. Here in the next clip, we'll look at the control panel. So if you haven't already figured this out, the first few clips we're going to be getting associated with the equipment, and then shortly thereafter we'll probably start getting into some of the preparations, such as the battery cabinet itself and probably some of the mounting brackets and materials.